Good evening. My name is Tim Burbey. I'm the president and co-founder of Blueshift. It's wonderful to be here with you. So, you may wonder why I chose to do the last slide of the day. It's quality over quantity. I knew if people showed up now, they really wanted to be here. And we love talking about thermal protection systems. And today we're going to talk about boosting the survivability of carbon fiber composites with lightweight thermal and flame barriers. I am going to need your help, though, right? Everybody's tired. Or is anybody tired? I'm a little bit tired. But I'm going to need your help. We're going to make it a little bit interactive. And as we go through the presentation, I'm going to give 2 fake data points, 2 false, I guess. And the first person to identify both gets a free box of Air Zero tape, thermal protection system. This material has been on spacecraft and aircraft, so it's the real deal. Retail at least $80. Not very liquid, so if you do win, you're probably not going to get $80 for it. But anyway, let's have some fun and get into it. Okay, quick overview. I'm going to tell you a little bit about Blueshift and our product line, and share our air and space heritage. We got to have some credibility if we're going to really talk about thermal protection and boosting the survivability of composites. Shout out to Becky Veely, our marketing manager, for this pretty cool graphic she put together. If you look at the bottom left of the graphic, you see some aircraft. One is electric, built and designed in Munich. The other one is not a combustible aircraft. I often make this mistake, right? So it's a combustion engine aircraft, and that's not a very funny joke by me, but we'll try to keep it going. As you get a little bit higher up, there's a space plane. And that space plane goes all the way up to the Kármán line and comes back down. So it's got its own unique challenges with heat. Does anybody in the audience know how far the Kármán line is? Tough for me to see hands up. I think I recognize you, but what do you think, Becky? Yep, Becky's spot on. It's about 100 kilometers. You'll also see in low Earth orbit some satellites. We're really proud to be part of some of the constellations that are going up. Satellites have a really tough life, right? These are orbiting Earth, and their day is really short. It's like 90 minutes. So 45 minutes hot, 45 minutes cryogenic. Sees big swings in temperatures. And they're going to be up there for like 5 years. So I always think about our satellites up there. They've got a pretty tough life. And then we're also on rockets. So we're both helping rockets as they ascend, as well as re-entering the atmosphere. And then you'll see that next graphic is part of the Moon Space Station. That'll go up in 2026 as part of the Galaxy program. And that's going to help us have a more permanent place around the Moon to do more exploration, as well as to have a kind of a base camp for deep space exploration. If you look really closely at the Moon, you'll see something that looks kind of like a top hat, and that's a moon lander. And the Moon is a full 1 million kilometers away. So Blueshift right now has materials from all the way from the Earth to a 1 million kilometers away. So hopefully that gives us a little credibility to share with you guys. So we will talk some more about thermal protection systems. Do we have any engineers or scientists in the audience? We got a couple. All right. Well, you guys know about types of heat transfer, so we're going to be really short on that. I've just got one slide to give a brief. And then we're going to get into the exciting part of the presentation, which is data, right? So it's wonderful to have a story, and we can tell everybody that our material is on aircraft and spacecraft, but the customer always says, show me the data. So we'll just share a couple of tests we've done One is direct contact heating, and the other is flame. And then we'll go into the conclusions. Why are we here? For Blueshift, it's all about making composites more economical. The change agents and the disruptions that need to happen, they got to make sense. And we feel like we can help the composites industry overall become more affordable and get greater traction and use. Okay, just a couple more overarching points. Megatrends, right? I think it's pretty interesting, after the Wright brothers first flew the Kitty Hawk in 1911, right, up until we walked on the moon in 1969, there was a lot of disruption in aircraft and spacecraft. After that, it was more about optimization. The Boeing narrow-body aircraft was first designed in the mid-50s. And so, we've seen better engines, overall better electronics for sure, but nothing really disruptive until, 5 to 10 years ago. Of course, SpaceX is an obvious one, but companies like Rocket Lab, right? Rocket Lab with their Electron rocket has been a big leader in getting materials up into space. And they're from New Zealand, which I think is a really great story. There's aircraft guys, like Joby and Archer and Lilium that we mentioned before that are designing a new aircraft. So it's really an exciting time to be part of material science. And then there's this whole subject around decarbonizing air travel. It's a really big story, trying to get to net zero in Europe, using different types of fuels. There's also not just electric aircraft, but hybrid aircraft. And I think it's also really interesting that, with electric aircraft, everybody thinks about eVTOLs. But there's also conventional takeoff and landing aircraft that are electric as well. Beta Technologies out of Vermont is a company that's engaged in that activity. All right, so what are the material technology companies going to do? How can we participate? Lightweighting, I know that sounds like kind of an obvious one, but that's what our companies really value, and that's why they contract with us. And it becomes more and more important the higher you get off the ground and the faster you want to go. And then resource efficiencies, right? Doing more with less. We feel like we can help companies design much more efficient systems that will use a lot less material, and then also can be applied a lot easier and faster, which also saves them a lot of money. Right, and then the demand. At the end of the day, it's really hard to raise investor money for advancing new technologies if there's not demand. And there's been a huge increase in vehicles being built and designed, facing new challenges. And so certainly we're seeing this increase in demand for flame protection, as well as higher temperatures for the thermal contact materials. And there's that word data again. Data creates confidence. It's really hard to sell stuff without data. We've done it, but it's a little bit of smoke and mirrors. So you got to give them the steak and potatoes, which is data. And the data helps us do our own thermal modeling, and thermal modeling just helps the whole cycle go faster. We're able to really predict what materials will work best in which environments, and that helps the whole process go faster, saves resources, both at our company and our customers. And we have a supercomputer, which it's really expensive to do these calculations in the modeling, and so you need special equipment. We've invested in that. And it's really all about design efficiency and helping our customers have flexibility in their designs. So it's super important for companies as they engage in aircraft and spacecraft builds to have as many tools in their toolkit as they can, and to make it economically feasible to launch their aircraft. Okay, it's not happy hour, but I really need a sip of water. I'm not sure if they're serving beverages in the crowd. It's really hard to see with the lights. And I can't hear the laughter over the noise in the hall, so sorry, I'm entertaining myself a little bit up here. Okay, back to credibility. show us what you've done. And this is meant to really just highlight, okay, we've been in all these aircraft and spacecraft, and we have a portfolio of products to handle different situations. And that's really important. And you only get that through experience. We talked about data collection. Also, all the internal testing we're doing with tons of different materials. We've really gained a lot of experience. And it's very collaborative. So just want to really highlight that in order to handle all these types of vehicles, you need to have a product portfolio. Okay, core technology. Our core technology is branded Aero Zero. Okay, and I'm going to ask a question in the audience. This is a really hard question, so don't feel bad if you don't know the answer. And pretend I'm holding up a sheet of Aero Zero. It's just a letter size piece of paper. Feels like paper. How many air pockets are in that single sheet of paper? Okay, somebody knows the answer. Benoit's feeling it. Benoit, how many? Excellent answer. Yeah, and I made the mistake of actually putting it on the slide, so good job, Benoit. Right, so our core technology is mostly air. Air is an excellent insulator. It's actually 85% air, nano-sized air pockets. Feels like a sheet of paper. People really are surprised that it's porous. But it does an amazing job protecting our customers' vehicles because it's really low in thermal diffusivity as well as thermal conductivity. And I'll show a slide on that in a couple minutes. So people are often surprised at how thin our solutions are, and that's the magic on the inside. Everybody remember Intel on the inside? For us, it's Aero Zero on the inside. And this comes down to lightweighting again, right? Our customers value our technology because we save them money mostly through lightweighting. Often people say, your stuff must be expensive. It's used in aerospace. Well, it's valuable, and it's valuable because it saves our customers money through the lightweighting aspect. It's also RF transparent because it's mostly air, and therefore we have nice applications in antennas, radomes, and cables, and sometimes customers even need both, right? A high temperature thermal protection system that is RF transparent. And all this lightweighting enables them to design vehicles that can go farther, go faster. And it's, and for an airline, their most expensive line item is fuel. And even for electric aircraft companies, right, it's energy. So we can help them use that for something else, for bigger payload, going faster, going farther. And I mentioned a little bit about installation time, right? So installation is also really important to our customers, and we help them install much faster than legacy materials, right? And this becomes more and more important as they want to make thousands of vehicles, right? Historically, there were only a handful of Apollo capsules built, right? So why did it really matter if it took a long time to do the integration? But today's vehicles demand something that's installed much faster. Okay, product integration. We make a flexible material. When we show you the data, one of the star products actually has a lot of flexibility to it. People are often surprised by it. Be fun if anybody wants to come by our booth the next couple of days, you can check it out. But we have a lot of installations that have double curvatures, round shapes. So our ability to provide a flexible solution is super valued by our clientele. Probably easily my favorite slide that we present at Blueshift is this graphic that shows the combination of low thermal conductivity and low thermal diffusivity. The reason it's my favorite is because it was so dang hard to come to this point. So we have the headline says thermal protection versus insulation. When we started out, we thought we were going to be making an insulation material. And just through pure grit and hard work, we came to the realization that our product works better than anything on the market when it comes to mitigating transient thermal events and cycled heat. So insulation, everybody knows, right? Your house has insulation. You got windows that are insulated. It's really easy to capture that. So this concept of thermal protection is really a different animal, and that's what Blueshift specializes in. Okay, now a little bit more on thermal protection. Give everybody a minute to look at the graph there. I think I heard a few wows. This is actually a little bit old data that's kind of a sneak preview to the updated stuff. But it's a 1,000-degree flame, and we were able to have a delta T of roughly 700 degrees or so. Now, when we talk about thermal protection, there's a lot of different things we have to take in consideration. These are really dynamic environments that these vehicles are experiencing. Right, so we got to think about time. We already talked about these cycled events versus steady state. It can be seconds for some things, can be minutes, can be hours. Of course, the temperature is a big deal. What type of temperature drop is the customer looking for? What's the distance from the heat source? What's the what are we trying to protect? You know, for this audience, it's usually composites. We also do work with lightweight metals. So maybe I shouldn't say that too loud. For the extended audience. Our customers always have programs that have weight requirements and flexibility requirements and design space limitations. Thermal protection is usually at the end of the design cycle. I know, I agree, they should really think about thermal protection first. But oftentimes we get engaged at the end. I mean, the bonus is sales come a little bit quicker when you're at the tail end of their build cycle. But it does create challenges, and our team actually loves it. It gives us a chance to engage and be creative. Okay, and we got a bunch of materials listed up there. It takes a village. You know, our product is not a panacea. We do think it's the best in the world, but most of our customers are still using a lot of legacy materials. You know, ceramics are still really common. Mica, cork, fiberglass. We use all these materials in conjunction with AeroZero. Yeah, so AeroZero is a wonderful additional tool to have in the designer's toolkit. Okay, remember I asked if there were any scientists or engineers in the room? I'm not one, by the way, so I had to do this for myself and really study it. But you know, there are 3 types of heat transfer: conduction, convection, radiation. Key point is all these vehicles experience more than one, right? There's no single type that these vehicles face. One will be usually predominant, but we have to take into consideration these different types as we do the modeling. Okay, now we're going to kind of do a speedy read through these experiments. Data, it's almost 6 o'clock, right? We're not going to push you to sleep talking about data. But like I said, we got to. It's our responsibility to make sure that our customers are comfortable with the designs we're providing for them. Okay, so first test is conductive heat testing. 20 minutes, 500 degrees C, just a simple stainless steel heater. And like we said, it's direct testing. Think about being on the beach, right? You're on the beach in Spain, you feel the hot sand on your feet. You know, that's conductive heat. 200 degrees temperature drop, it's 40% from 500 to 300. So for us, this is dramatically showing how effective our material can be. And again, these are very thin solutions. This one is under 1 millimeter. Okay, now people usually get a little more excited when we talk about flames, right? If the party's a little slow, get a fire going, get a torch, and the room lights up. So this one, 15 minutes, 1100 degrees C. Remember earlier we talked about the temperature was 1,000 degrees, so we upped it 100. And it's a propane torch, about 2 inches, about this much below the testing configuration. And drum roll, please. 750 degree drop in temperature, and that's about 70%. So again, these are thin materials. Our best performing one, and I'll show a magnified view is actually closer to 2 millimeters thick, but really tremendous capabilities with still fairly thin materials, and mostly it's dependent on thickness. Now sometimes you can mix in something else that will actually be a little bit thinner and be more powerful against whatever test you're running. In this case, it's actually not the thickest material that performed the best. Okay, and real quick, these are just some pictures of the materials after they've gone through the test. Super important for our customers that it survives intact and it keeps its mechanical strength. Again, we have a portfolio of products. These is just 5 of them. We have about 20 that we sell. Really important for us to have this data to input into the simulations so that we can give good recommendations. Right, so 2 experiments, big temperature drops. First one, direct contact heating, dropped at 40%. Second one, flame test, anywhere from a 550 to 750 C temperature drop. Okay, who's seen this movie, Christmas Story, right? Ralphie's little brother is getting dressed up by his mom. He's going out in the snow. I mean, the poor kid can't move after he's got all this stuff on him. That's not how we think when we do our thermal protections for aircraft, right? We're thinking of these Olympic skiers with svelte jackets and pants with their composite skis. And so we want to design as efficient and effective and economical thermal protection systems that we possibly can. And it's really our big effort to help this industry become more cost competitive and grow as fast as it can. All right, so I've left just a couple minutes for questions. Really appreciate everybody's patience after a very successful, busy day. Any questions for me? All right, well, please enjoy the rest of your show. Oh, and happy 60th anniversary, JEC.